April the 5th. We're running ground penetrating radar for this particular project. We're utilizing GPR. It's a non-invasive way of detecting things underground. What it basically does is it sends EM, electromagnetic waves, into the ground and refracts off different objects with different dielectric properties. So based on that, this particular application, we're looking for an underground storage tank, a UST, that has been suspected to be removed and or not removed, but we just ran ground penetrating radar over here and determined its tank location, and now we're going to do some invasive drilling using direct push geoprobe technology. So we hope we're going to take soil samples within the borings adjacent to the tank that we just located utilizing ground penetrating radar, and then we're going to take soil samples and screen them using a photo ionization detector, or PID, that analyzes VOCs, volatile organic compounds, and then send them off to the lab and write a report, and hopefully for these young folks here, they have good results. Basically right here where I'm standing, you can see the trench come down. So there's your top of your layer right here. It looks like this is a lot of debris in here, but here's your limits of excavation, and there's your tank right there.
All right.
This is Rocky. He does all of our drilling in the state of Virginia, and I'll turn it over to Rocky.
I'll be taking this core sampler, 4-foot long core sampler. And I'll go down, of course the first one's going to go down to 4 feet, and then I'll just keep on adding on 4-foot sections to get to the depth that we want to get to, which is going to be 16 feet. So we're hitting groundwater about 14, 15 feet. That's what we're going for. We're just down to 4 feet, and this is our first 4-foot core sample.
What we do is, this is the zero sample, so what we classify this column under the Unified Soil Classification System, and we're going to bag every 2 foot. So, and then basically we're going to let that sit, and then we will screen those with a photo ionization detector, and from that we determine our lab samples.
Okay.
So what I'll do now is basically, here's your 0 to 2. This is a 4-foot screen. Petroleum constituent. You don't want to look for any staining or any, anything that smells or any sheens on it that looks like petroleum-based products. But I'm not picking anything up here. too, this is called a mottled clay. So that means that the groundwater table is fluctuated up and down through this. So that means usually your contaminants are going to be either sitting on or in this zone usually. So that you see the different mottled, the groundwater table has been going up and down through this material. And this is classified as a sandy clay, or under the Unified Soil Classification as a CL. That's the abbreviation for that. Well, we've hit the groundwater table, so basically that's where we stop. So you don't want to advance the hole past the static groundwater table with too deep, because you don't want to, you don't want the contaminants to leach down further down into the groundwater table if they're there. So with that being said, we terminate the boring at the groundwater table depth, or in that zone, and then we want to take back out the hole, and then you want to drop down a screen and a peristaltic pump, and then start taking your sample at that depth. What he's going to do now is let it stabilize and try to get a depth. He's going to drop these down and try to get a depth to where he's at.
This is what it's showing this.
Yeah, it's a sleeve inside.
That's the actual screen.
Yeah.
And what's kind of interesting about this is this is actually a V-wire screen. So you see these little bumps are just little, like 16-inch stainless steel round stock that runs vertical, and then this wire is just one wire that wraps around it.
It's not cheap.
And it's a V wire. No, it's not.
No.
You don't want to drop this.
No, you don't want those dented up either.
So the reason it's a V wire, so the slot gets bigger as it goes in. So if something starts to come in, it'll most likely make it through because the gap's getting bigger. That's the point of having a V wire. They use them a lot in the food industries, you know, sodas, any kind of juices. And what it does, this is with a Tygon tubing, and it has, if you look, there's 3 rollers, like drum rollers. See, when they spin, there's always 2 rollers in contact with this tubing. And so what it does is always pushing the airspace forward, and that's how it draws the fluid up. They use them in the food industry because they never had to worry about anything getting contaminated because it's all just in the tubing. They don't have to worry about seal blowing or you got oil coming into your food.
Okay, we're now sampling the groundwater table in an amber 1 liter jar that will be iced down to below 40 degrees.
And how many of these do you have to collect?
This particular, we're sampling for total petroleum hydrocarbons, so we're going to take 4 of these vials actually.
Maybe your wife will. No.
Now, does the hose have to be flushed in between each one, or?
You basically, this tip, yeah, you use new hose. And you decon with Alkanox. That's what he's doing right now.
With the hose, the actual clear hose itself, do you run something through?
You use new hose.
New hose? Okay, new hose each time, okay.
Right. But this is the only actually sample we're taking, so really, you don't have to reuse this one. Okay, we've completed our drilling. We drilled 3 holes and we bagged all the samples every 2 foot, and I've let them sit in volatiles. And what I'm going to use now is a Mini Ray 2000 that's been calibrated, and I have a filter on the top just for protection. It basically sucks air inside. It has a photoionization detector that measures VOCs, or volatile organic compounds. And just so you can see, you can take a Sharpie, and there we go. We're getting readings right there, and 5.8 parts per million is what this reads in. So it's pretty accurate. All right, I'm going to start my screening process. These have been sitting for about an hour. There's really no standard on that. I just like to let them sit, and I call it cooking, to let the soil cook, and if there's any vapors coming out of it, we'll pick it up. So I'm going to press this inside the bag and kind of cup it around, and nothing there. So, but I'll mark these down. That's a 0 to 2 sample, and we got a reading of 0.2 parts per million, which is nothing. And I'm going to go to 2 to 4. .4, a little higher. And 4 to 6 in depth. And this soil is coming directly out of the soil column that we just removed from the ground. And as you can see, I'm getting about 0. I usually let it sit there for a second. 0.6, 0.7 parts per million. 12 to 14. One part per million. 14. 0. That's right about where the groundwater was, so that's the highest reading I've gotten, which isn't much, but yeah, we dropped down to 1.5. So now this is actually below, yeah, this is actually below the water table, so that makes sense. We're at 0.4 parts per million. So with that being said, my highest reading was a 12 to 14 sample, and this is basically right above the groundwater table. So that's where I would be testing my sample, packaging this up, and sending to the laboratory to be tested for TPH VOCs.